Atomic radii. Radii is a plural form of radius, and here we are going to discuss about atomic radius, means the radius of an atom. The radius is a very common word. You might have studied about the radius of a circle. This is a circle given here, and to measure the radius of a circle, we measure the distance from the point from the center of a circle to any point on the circle. This line represents the radius of a circle. In a similar manner, we measure the radius of an atom. It is the distance from the center of the nucleus. Nucleus is the central part of an atom to the outermost cell of an atom. This is the atomic structure of an unknown atom is given here, and this central part is nucleus. I will mention here nucleus, and so this is the outermost cell. And to measure the radius of this atom, we measure the distance from the nucleus to the outermost cell. And you can see these circles are known as cells, and when the number of these cells increases, the radius of an atom also increases, and if the number of these cells decreases, the radius of the circle, the radius of the atom also decreases. So overall we can say that the radius of an atom depends upon the size of an atom. If the size of an atom increases, the radius of the atom increases too, and if the size of the atom decreases, so does the radius of the atom. Here we have periodic table, and this periodic table shows the atomic radii of elements in nanometers, and visually you can see that balls, the size of balls shows the trend of atomic radii in the table. If we look from top to bottom, the size of ball increases. It means that atomic radii of atoms increases, and it decreases from left to right in the table. And the question is, why does atomic radii increases from top to bottom, and why does it decrease from left to right? The reason is that atomic size increases from top to bottom because the number of periods increases. Number of periods is equal to number of cells. It means that when we move from top to bottom, the number of cells increases in an atom, which result in the increase in the size of an atom. And when the size of an atom increases, the atomic radius of an atom also increases. Now let me take ionic radii. Ionic radii of ions is measured in the same manner as we do measure the atomic radii of atoms. It is ionic radius is the distance from the center of the nucleus to the outermost cell of an ion. And before I discuss the trend of ionic radii in the table, let me introduce an ion. An ion is formed when an atom loses electrons or gains electrons. When an atom loses electrons, it forms positive ion. Suppose that X is a neutral atom and it loses one electron. It carries positive charge. This one positive charge shows that this neutral atom has lost one electron. And so this fact can be explained by using the diagram. You can see that this is the atomic structure of sodium atom, and it is having 11 electrons in its cell and 1 electron in its outermost cell. And when it loses 1 electron from its outermost cell, it carries positive charge. One positive charge shows that it has lost 1 electron. And if we look at the atomic structure of sodium ion, it is carrying only 2 cells because In the outermost cell, it does not carry any electrons, that's why it is left with only 2 cells in which electrons are present. And when we compare the size of neutral sodium atom with its ion, with sodium ion, the size of sodium atom is larger than the size of sodium ion. So here we can come to the conclusion that when an atom loses electron, its size decreases. But in case when an atom gains electron, suppose that Y is a neutral atom and it gains 1 electron, and when it gains 1 electron, it carries negative charge, and this fact can be explained by using the diagram in better way. This is the atomic structure of chlorine atom, and it is having 17 electrons. In its outermost shell, it has 7 electrons, and it is having a strong tendency to gain 1 electron to complete its octet. It gains 1 electron, and when it gains 1 electron, it carries negative charge, and 1 negative charge shows that it has gained 1 electron. This is the electron it has accepted. And when it gains 1 electron and 1 extra electron enters into its outermost shell, the size of outermost shell extends due to the entrance of an extra electron. And when we compare the size of chlorine atom with its chloride ion, you can see that the size of chloride ion is larger than the size of Cl atom. So here we can come to the conclusion that when an atom gains electron, its size increases, but when an atom loses electron, its size decreases. Using this fact, we can explain the trend of ionic radii in the periodic table. This is the table is given here, and this table shows the trend of ionic radii. And so in this table, S block and P block elements are included. In S block elements, you can see that beryllium is losing more electrons than lithium. That's why the size of beryllium is smaller than that of lithium. And same case goes with P block elements. Carbon is losing more electrons than boron. That's why the size of carbon is smaller than boron. But in case of nitrogen, nitrogen is an element, a nitrogen group elements are having a tendency to gain maximum number of electrons. That's why its size is much bigger. -3 charge it is carrying. That's why it means that it has capacity to gain 3 electrons. And oxygen gains only 2 electrons, fluorine gains only 1 electron. So that's why if we compare the size of nitrogen, oxygen and fluorine, so the size of nitrogen is much more larger than oxygen and fluorine atom. And similarly, here's the same trend we find here in the 3rd and 4th period also. But when we look from top to bottom, obviously atomic size increases, and when the atomic size increases, atomic radii increases and ionic radii increases too. You can see that the size of balls are given in an increasing order. These are having increasing trend. But when we move from left to right, we need to consider the capacity of an atom to lose or gain electrons, how much it gains electrons and how much it loses electrons. Based on that, we can explain the trend of ionic radii in the table.